section 23.1, page 341. This is question 6, and it's been given a grade A star rating as opposed to the previous video where it's an introductory grade A. 3 little questions here. It says find the shaded areas. It says there, find the shaded areas. Okay, we'll do that. Now, what do we got here? We have got, if you like, a quarter of a circle. Just ignore this for now. We have a quarter of a circle, and there is the arc there, coming back round and back again. So that is a quarter of a circle. Essentially what we need to do, if we can speak about it, is to work out the area of a quarter of a circle, and I'm told the radius equals 12, this part here. And if I work out the area of a quarter of a circle and subtract the area of a triangle away from that answer, then I'm going to get the little pink bit, aren't I? So let's have radius equals 12 here as well. So let's just do it in bits and pieces. So we've got a quarter of a circle, okay, just accept that, there it is going round, quarter of a circle. So we can have quarter times pi, 3.14, times radius squared. Let's get a sub answer, 0.24 times 3.14 times 144, well that's 12 squared, it's famous. I've got 113.04 centimetre squared so far. The area of the triangle will be half times the base of 12 times, of course the height is 12 as well. So that's going to be a half of 144, which is 72 I believe. So it's 72 centimetres squares. Therefore shaded area is going to be the entire quarter of a circle, take away the area of the triangle. Let's just do that quickly. So take away 72, and I've got there 41.04. I'm just going to call it 41 centimetres squares worth of area. Okay, let's do that. In fact, let's just check the answer quickly. Number 7, 23 point Dewberry, 41. Not question 7, it's question 6. Yeah, 41.1. Well, they've gone 41.1 because I think they're using the entire decimal places for pi. So if you multiply by 3.1415926, etc., and all the other spaces that fit on the calculator, then you get a slightly bigger answer, aren't you? But that's plenty good enough. 41 point nothing is great. Now, that's that one done. Let's just do B right here. That's that one there. And we're working out the area of that sector there, clearly so. And the radius is, back to pen, and the radius is going to be right there, 4.5. So I wrote it in the relevant place. That's 4.5, and so is that. It's very straightforward. It's based on pi r squared, clearly so. So we have this fraction of the area of the circle, which is times pi, times the radius, which is 4.5, and it's squared, okay? Pi, r, and there's the squared. And it's this fraction of that area. Again, do it one step, why not? So 134 divided by 360, that fraction of pi, which is 3.14, times 4.5, and hit the square button. Bam, there it is. We make it 23.66, so I'm going to go for 23.7 centimetres squares, because we're now talking about areas, aren't we? And the last one I'll probably fit just there. Let's just separate this off a little bit and get it to fit in this little corner here. Right, so, oh, by the way, this is like Weymouth. It's beautiful, isn't it? This is Weymouth. Again, we visit there a lot. Lovely backgrounds, lovely seaside, beautiful place to live. And one day I hope to go there and, I don't know, just have fun. Right, what we got here? Area of this little thing. Now, be careful. The 100 is outside the shape. If I'm the area of this lovely shaded piece of cake, I need to work out the angle that's relevant. So 360, take away the 100. I've got 260 degrees to play with, not the 100 to play with. So what do we got there? The area of this part. Oh, by the way, forgive me. The radius there is 62 centimetres. So let me say in black and white, or rather red and white in this case, and that's centimetres. And now I'm going to use that to work out the area of this lovely pinky beautiful little thing there. So it's this fraction, 260 over 360, it's this fraction of pi times the radius squared. I'm not going to change it into anything and leave it in centimetres. Get a huge answer. So there it is. Well, lots of centimetre squares worth of space, shall we say. So I leave it as it is. So this fraction of pi times radius squared, I think it's 62, not 6.2. Mine's don't, yeah, I think it's 62. Right. 260 divided by 360 times 3.14 times 62 squared. Big number. Too big, I don't like it. 8,717.3 centimetre squares of area. Let's see if they changed it into metre. No, they did not. What have they gone for? They've gone for 38722. Well, mine's slightly lower again because I'm not using the full-blown pi. Let's see what happens if I do use the full-blown pi on my calculator. So it'll be 260 divided by 360 times, now where's my pi button? I mean, I never use this button. So, oh, there it is down the bottom. So shift pi, got it, times 62 squared. Yeah, 8721.759, what they say. 8722, going to, the nearest whole number. But if you can see that, so I've used the entire pi button there. I think you can see the pi there if you look carefully. But I'm happy enough with that, using 3.14. In fact, I've said I'm using 3.14. I've never actually wrote down pi to use as such. So that's good enough. Depends how long this video is, whether I'll stop or do some more. Let's just carry on. If it's a bit long, I just edit it. Next little bit. Tricky. We're into A star territory for some of these. A little bit tricky. A is dead easy. It says, this is question 7, find the shaded areas, okay? The arcs are quarter circles, so that's a quarter of a circle, so that's a quarter of a circle, and the squares have sides of 10 centimetres. So all of these are 10s, so the radius is 10, that's a 10, that's a 10, okay? It's not, the whole thing isn't 10, each little bit is drawn as a square 10 by 10s, and of course that's a 10 by 10 as well. I'm not looking forward to 7C, I really have to think about that one. But anyway, what have I got here? Find the shaded areas. Essentially, I've got the area of a square, 100, clearly, 10 by 10, and then I'll take away the area of a quarter of a circle, and I've got the green bit that I want. Why don't we try and do this in one step? So this is me doing A. I want the area of the entire circle, the entire square, which is 10 by 10, 10 squared, then take away, that's a quarter of a circle, then take away a quarter of pi, 3.14, times the radius squared, which is 10 squared. Now, if you're not comfortable doing it in one big step, no matter, just break it up into little bits. 100, take away whatever this is, and then get the final answer. But I'm going to use one step. This is A star. I've shown I can substitute the correct numbers in the correct place and use the correct formula. And so, let's just go for it. So it's 100, take away 0.25, that's a quarter, times 3.14, that's my pi, times 10 squared, which is 100, and in one step I've got an answer of 21.5 centimetres squared. So that little green thing right there is 21.5 centimetres squares worth of area. It makes B very, very easy, because essentially there's A, there's another little A question. I've got 4 of A. Alright, so I'm just going to multiply this answer by 4. Why mess about? Now, of course, if you were given this question B as a standalone question in the exam, you would of course have to work out the area of one little green portion, here for example, and using this method in A, and then just multiply by 4. So all I'm going to do is say I've got 4 lots of 21.5, and therefore here I go. So 21.5 times 4, that gives me exactly 86 centimetres squares worth of area. Now, C looks like a complete pain. Right, what have we got here? Study what I'm about to do. This is my thinking. The radius is 10, clearly so. I want just the green bit here. I can't get the green bit. I've got this beautiful elliptical shape and I can't do it directly. Now look, I've got a quarter of a circle. Just follow my pen round. Right, do it one more time. This is a quarter of a circle. So if I could work out the area of quarter of a circle, and then let's just move to this, and then work out the area of the triangle, which is half base times height, I can take away the area of the triangle from the area of quarter of the circle, and what that will give me is this area here. Okay, one more time. I'm going to work out the area of a quarter of a circle, including the white bit and the green bit here, all this, work it out, then work out the area of the triangle, subtract them, and that will give me the shaded half that I require. Once I've got the area of the shaded half, I'll just multiply it by 2, because this side equals that side. Alright? Visually, absolutely acceptable. So let's just do this first. Let's just do it in bits. So quarter of a circle then, here we go. So that's going to be quarter of pi times the radius squared, and let's just get that answer first. 0.25 times 3.14 times 100. If I press the right buttons, this is what I've got. I've got 78.5 centimetres squares, taking pi to be 3.14. So that's, I've worked out all of this area across here and all that shaded in. Now, area of the triangle is going to be half times base times height, and of course half of 100 is 50 centimetres squared. So from here to here, and all the area to the left of this solid yellow line is 50 centimetres squares. Therefore, the area of this yellow shaded part here in the green zone will be 78.5 take away 50. So here's my next step. 78.5 take away 50. I can see that's going to be 28.5 centimetre squares, and therefore the area of the entire green bit will be that times 2. I've got 2 halves, haven't I? Therefore 2 times 28.5 will be, get my calculator, 28.5 times 2 is going to be 57. So I make that 57 centimetres square. The book makes it 57.1 because they're playing with proper pies, and I can't be bothered with that. So I'll stop that now. It's going to be a longish video, so study that, especially part C. Still very satisfying though.